Allison. Welcome to Math Bytes. Today we're talking about simplifying square root expressions. When working with square roots, sometimes the number under the square root symbol is a perfect square and sometimes it isn't. Even if the value under the square root symbol isn't a perfect square, you still might be able to simplify it. And in math, we're big on writing things in simplest terms. So if we have the square root of b for some number b, ask yourself this. Is b a perfect square? If b isn't a perfect square, can you write it as the product of a perfect square and another number? Now, before we go on, let's go over an important concept by way of an example. So, if I have the square root of 16, 16 is a perfect square. It's 4 times 4. So I can rewrite the square root of 16 as the square root of 4 squared. Now, simply put, that square on the 4 and the square root cancel each other out. So all I'm left with is the value I'm squaring. So the square root of 4 squared is just 4. Now, it's important to understand that concept when simplifying square roots. Let's take a look at our first example. We have the square root of 75. Now, is 75 a perfect square? Meaning, is it the product of a number with itself? No, it is not. All right. Can I write 75 as the product of a perfect square and another number? To figure this out, just roll through a few perfect squares and see if something looks promising. So a few perfect squares are 4, 9, 16, 25. How about 25? I can rewrite 75 as the product of 25 and 3. So let's do that. I have that the square root of 75 is equal to the square root of 25 times 3. Now I'm going to rewrite 25 as 5 squared. So I get the square root of 5 squared times 3. Now that product under the square root symbol of 5 squared and 3 can be broken up into 2 square roots. So I get the square root of 5 squared times the square root of 3. Now, just in our previous example with the number 16, the square root of 5 squared is just 5. The square and the square root cancel each other out. So I am left with 5 times the square root of 3. This is as simplified as this gets. So the square root of 75 is 5 times the square root of 3. Okay, let's look at example 2. We have the square root of 45. Again, ask yourself, is 45 a perfect square? No, it is not. Can I write it as the product of a perfect square and another number? Think about some of the factors of 45. 9 times 5 is 45 and 9 is a perfect square. So I'm going to rewrite this as the square root of 9 times 5. Now I'm going to rewrite 9 as 3 squared. So I get the square root of 3 squared times 5. Now, the square root of 3 squared is just 3. Again, those two operations cancel each other out. So I'm left with 3 times the square root of 5. That is the simplified version of the square root of 45. Okay, let's look at our last example, example 3. We have the square root of 60. Now, 60 has a few more factors than some of the other numbers we've been looking at. For example, 6 times 10 is 60, but neither 6 nor 10 are perfect squares, so that won't help us in simplifying this square root. Are there any perfect squares that are factors of 60? What about 4? Yes, 4 times 15 is 60, so I can rewrite the square root of 60 as the square root of 4 times 15. I'm going to rewrite 4 as 2 squared, so I get the square root of 2 squared times 15. The square root of 2 squared is just 2. So I end up with 2 times the square root of 15. Now, it's always a good idea to check what you have left under your square root symbol to see if you can simplify any further. What I have left under my square root symbol is 15. Can I write that in any way to pull another square out that's going to get me anywhere here? No. 3 times 5 is 15, and neither of those are perfect squares. Now, 1 times 15 is also 15, and 1's a perfect square, but I'm still just left with the square root of 15. So this is as simple as it gets. The square root of 60 is simplified as 2 times the square root of 15. Simplifying square root expressions comes in very handy when working with the quadratic formula. It's also part of the larger topic of simplifying radical expressions. So if you can understand the concepts we've gone over here today, you'll find simplifying radical expressions pretty straightforward. That's it for this episode of Math Bytes. If you like our videos, please subscribe to our channel. And if there's something you'd like to ask us, why don't you email us? We are at contactmathbytes@gmail.com, and I'll see you next time.